Okay, so after arithmetic sequences and looking at the how to write the formula for it, we're going to look at now explicit formula for geometric. Remember, geometric has a common ratio, what you're going to multiply by each time. And the formula for geometric sequences is to find any number term, you take the first term and you multiply it by r to the n minus 1. And now why is that again? Think about it. If you want the fifth term and you're multiplying by, say, some number every time, you take the first term and you multiply by that number, 5 minus 1, 4 times. So how many times are you going to multiply by the common ratio? So for example, let's jump right into one. A sub n equals negative 2, 4, negative 8, 16. So we hopefully can see this is geometric with a common ratio of times negative 2, right? Multiply by negative 2. So we know the common ratio is negative 2, and we know the first term is negative 2. Well, that's annoying, but it is. So we get to find any term, it's going to equal negative 2 times negative 2 to the n minus 1. So if you want the seventh term, and you could just sit here and kind of find it, multiply by negative 2, you get negative 32, times negative 2 is 64, times negative 2 is negative 128. It should work. You could do it the long way if you ever get stuck, but if you want to use the formula, and here it is, to find the seventh term, it's negative 2 times negative 2 6 times. So what is this? Well, we can do it in the calculator, and I think we already did it. It should come out to, let's see, negative 2 times negative 2 raised to the sixth, negative 128. Good. Okay. Number 2, diagram below represents the first three terms in a sequence. This one's kind of funny. I kind of felt silly kind of doing this. So the first term is 1. The second term has 6. And I'm going to guess this is 36, but I actually checked. I just went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 16, 17, 18, 19, 30, 36. There you go, 36. So hopefully we can see it's geometric with a common ratio of times 6. So it says, assuming the pattern continues, write the explicit formula for a sub n. Well, a sub n equals a sub 1 times r to the n minus 1, which is a sub n equals 1 times 6 to the n minus 1. Now, just like last lesson, if it doesn't tell you which type of formula to use, it's up to you. You could do it just by counting out. You could do it with recursive. You could do it with explicit. It's really up to you. So this says when a ball bounces, the height of the consecutive bounces forms a geometric sequence. The height of the first bounce is 121 centimeters, and the height of the third bounce is 64 centimeters. So to the nearest centimeter, what is the height of the fifth bounce? Well, we know the first bounce is 121. And we don't know the second, but we know the third is 64. So centimeters, centimeters. Okay, so how are we getting here? Well, what's happening? Well, it's going down by a certain amount, right? How much is it going down by? Well, 121 minus 64 is 57. So it goes down by 57, but that really doesn't help us as much here, right? Because you can't use that method of divide by 2. That's not going to help us. So what is happening here? Well, how do we figure this out? And let's see. Can we think about this mathematically? Well, it goes down. Well, it's not going to be like divide by 2, because if you divide this by 2, it's going to be something. So it's going to be multiplied by something, right? Well, let's think about this. So we get a sub n equals 121 times r to the n minus 1, right? So a sub 3, so 64 equals 121 times r to the 3 minus 1, which is 64 equals 121 r squared. Divide by 121. Let's see. 64 divided by 121, and we get this, and we take the square root of that answer, and that tells us that we're multiplying by 0.727272727272. Let's see if that works. So now we get a sub n equals 121 times 0.727272 to the n minus 1. And if we're looking for the fifth, that's 121 times 0.727272 to the 5 minus 1 fourth. Let's see. 121 times, I'm going to put answer raised to the fourth, 33.85 to the nearest centimeter. Yep, that makes sense. 34. It's a little trickier. Okay. Keep in mind I skipped a step here. I took this value. I took 64 over 121 equals, and now that I'm actually seeing this actually would have been a lot smarter. If I take the square root of a fraction where both are perfect squares, you get r equals 8 over 11. That would have made a lot more sense. I actually want to go back and fix that. There you go. Okay. I'm going to skip 4. I'm going to go to 5. 5 says, the recursive formula to describe a sequence below is shown. Recursive, so remember recursive, you need the first, and then you can write a formula, and you have to go 1 by 1 by 1 by 1. So it's saying the first term is 3, and then to find the next term, to find any term, you take 1 plus 2 times the term before. So it says state the first 4 terms. Well, we know the first is 3. So the second is 1 plus 2 times 3, which is 6 plus 1 is 7. So the third is 1 plus 2 times 7, which is 14 plus 1 is 15. And then the fourth is 1 plus 2 times 15, so it's 30 plus 1, 31. And it says, can this sequence be represented using an explicit geometric formula? So can you do this explicitly in a geometric way? Well, am I just taking the term before and multiplying it by something? So this is no. And why? Because look, this is not simply geometric. It's neither, because you're not only doubling it, but you're also adding 1. No, since we are not just multiplying the previous term, by 2, we are also adding 1. Okay, try the homework.